All right, let's talk about finding the range for group data. This is the part two. This is the continuation from the previous part where we got introduced to the concept of range as one of the absolute measures of variability. And we calculated range for simple problems like we took the Amazon phone example and we figured out that range is nothing but in the given data set, when you take the difference of the largest and the smallest value, you get a range. And we saw some exam problems like over here, find the range for this data set. We took the largest and the smallest value and then we got the range. That's what we did it. In this case, it's a simple raw data or ungrouped data, and hence we could find it. And if you remember in my first earlier episodes, while I was trying to talk about how to calculate mean for group data, I did introduce you to the concept of the group data. I think I spoke briefly about that, but enough to understand what is the concept. And again, I'll just brush upon those topics here because this is important and you are definitely going to get a question on this in the exam for at least 4 to 6 marks. So it's very important that we understand. All we need to understand is the given example is an example of a group data, and then how does the calculation vary, whether it's going to be for mean or it's going to be for range. It does not matter. We just need to understand that for group data there are some nuances that we need to understand. And a quick example, the same example we discussed in when we did this as an example of mean, we took the same example. We are going to take the same examples, and these are going to be examination problems. So what is a group data? So whenever you see this jargons like class interval over here there is no jargon, it's just marks, but doesn't matter. So whenever the given data, this is the frequency at the bottom row, number of students or frequency is the same. So ignore the denominator, so ignore this part, okay? This is just a frequency. But the raw data over here in the numerator or in the upper section, whenever you see in this in form of a range or a bucket, this is the bucket 1, this is the bucket 2, this is bucket 3, bucket 4 and bucket 5, right? Where you have an lower limit and upper limit, lower limit and upper limit. That means they're talking about a group data. And what does group data mean? Like if you see this example, this is very abstract because they're talking about class interval. Whenever they talk about class interval, it's group data. You should understand that. That's your cue. But if they don't talk about class interval, the way to understand this is, again, I'm repeating from the last episodes that I covered. How do I read this? For example, if this was a mark distribution for a class, and if this is the range or this is the bucket 1 or class interval 1, 2, 3, 4, the same stuff that we have here. The way we read this is 6 students in the class got marks anywhere between 10 to 19. 10 students in the class got the marks anywhere between 20 to 29. 16 students in the class got marks anywhere between 30 to 39. So like that, we are getting a range. We don't get the exact number like how we got here. Let's say if I say over here it's 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's say these are the marks for 9 students in the class. So it's exactly, I know that there's 1-to-1 mapping, one student and I have a specific mark, whatever is the mark for him, right? So I exactly know. So there is no grouping here. Whereas here the data is grouped, and that kind of introduces an ambiguity, because now if you see here, like I've explained at the bottom over here, let me get rid of this doodles. Okay. All right. So if you see at the bottom, how do I know in this both examples, if 3 students have got marks between 0 to 10, how would I know whether all the 3 students have got 0 marks or all the students have got 10, not 10 marks, sorry. It will be always less than 10. I'll talk about that in a minute. All the students have got 9 marks or 8 marks or 7 marks, or maybe one student has got 6, one student has got 2, and another student has got 3. So it could be anywhere. They could get anywhere between 0 to 9 over here. Similarly, over here, if you take 14 students have got in this range, so 40 to 49 is a range, okay? So that means we are going to talk about less than 49. I will talk about that in a minute. So let's say students would have got marks anywhere between 40, 41, 42, 43, and so on up to 48. All the students could have got different all these 14 students, I mean, could have got different marks within this kind of class interval, or it could be same, or it could be like two students have got 42 and one student have got 43. So I would not know that. So it could be, there is an ambiguity. And in the case of mean, when we calculated the mean, arithmetic mean, the way we did is we exactly took the midpoint. We assumed on an average, let's assume that all the students in a class interval could have got on an average of this interval. So whatever was the midpoint of this, 10 to 19, 20 to 29, we took that. For example, in this case, the midpoint was kind of 5. So 0 to 10, we took the average of that, and we assumed that all the 3 students could have got 5 marks in this class interval. In this class interval of 8 students, in this class interval, all the students would have got 25, because 25 is the midpoint between 20 and 30. That's how we kind of assume that. Similarly, there is a way to assume the midpoint for the range also, and we calculate that. Before that, let's understand what is the difference between these two examples of overlapping and overlapping and non-overlapping class intervals or boundaries. And again, this also I've explained, but just let's do a quick refresher in the interest of context. So if you see this example on the left, if you see this class interval and if you see this class interval, the boundaries, the upper boundary on this one and the lower boundary on this one, that is 10 and 10, they are overlapping, they are same. Similarly, if you take this one, the upper boundary on this class interval and the lower boundary on this class interval, which is 40, they are overlapping, and hence these are called as overlapping class intervals. And this is the example that we took in the case of the mean. And typically in mean, when you calculate mean for group data, you will always get an overlapping example. Whereas when you calculate the range in the exam, you'll always get this non-overlapping, where you see that if you take this class interval, these marks are nothing but class intervals. Okay, that's a jargon. There's a class interval 1 and this class interval 2. Let me write it down here. Hold on. So let's say this class interval 1 and this class interval 2. But if you see here, the upper limit of this class interval is 19 and the lower limit of the next class interval is 20. So they are not overlapping. Okay, that means apart from the ambiguity between this interval 10 to 19, I don't know the 6 students have got whether 10 or 11 or 12. There's another ambiguity between the class intervals. What if a student has got, say the class interval is 10 to 19 and then we have a class interval or a range called 20 to 29. So there is still a gap between 19 and 20. So where do students who have got 19.1, 19.2, 19.5, where do these students figure out? How will you know in which bucket or which class interval you should take these students? We will not know that, right? And that's the ambiguity. So non-overlapping intervals has got two sets of ambiguities within the class interval of the boundaries, upper and lower, and also between those two class intervals. Because of the non-overlapping feature, there's a gap, and we will not know if students have got marks between that range, how to bucket them. That's the overall concept. Okay. And all these things that I have spoken just now, I've already put here. And the way we'll solve this problem is, and this we have seen in the context of mean for continuous or overlapping intervals. It's another jargon. Either we call it continuous or overlapping, because there's a continuity. We have 0 to 10, like a relay race. Then we have 20 common here. So it's continuing. So the way we assume that is, whatever is the way we define the boundary for this is, whatever is the upper limit, that will be the cutoff. For example, when we say 0 to 10, we will not include 10 in this boundary. So if the 3 students have got marks between 0 to 10, at the most they can go up to 9, 0, 1, 2, 3, 4, dot, up to 9, but not 10. So it's like, if this is the mark of the student, it can be equal to 0 or it can be greater than 0, but it will be definitely less than 10. It will not be equal to 10. The 10 gets included in the next boundary. So if a student has got mark 10, he'll be always counted in this boundary where 10 is the lower limit. So if you see here, in this case, the value of x, which is a student marks, it shows equal to, or 10 is equal to or less than x. That means if a student has got marks 10, he'll be included in this interval and not in this interval. That's the first way you eliminate the ambiguity on where should you count the mark if a student has a mark on the overlapping boundary of, let's say 10, or it could be let's say 40. So if a student has got a mark 40, So 40 is over here also, and 40 is over here also, where you will count that. Since we are not going to count, this interval is going to be up to 40, less than 40. So we are not going to count this. So whenever we say a student has got mark 40, we will count him here only, because that is equal to or greater than 40 kind of comes here. So that's the first part, okay? And which is what we have done in the previous videos. And after we do that, after we calculate the midpoint, the simple way to calculate the range is, since in this case we are not calculating mean, in cases of mean we calculate the midpoint for each of them. But if you get a problem where you're getting a group data example with continuous overlapping class interval, then you don't have to worry. You simply calculate the difference between the last value, the 50, and the 0. So the upper value, upper limit of the last boundary, the last class interval, and the lowest boundary of the lowest class interval, the first class interval, and then you subtract. So in this case 50 minus 0, that's what you get over here. So that way we know that the range is 50, and this way this calculation is exactly similar to what we have done before here, where we calculated the largest and the smallest value. And mostly, like I said, you will not get a overlapping, you will not get this for the range problems, you will get this for the mean problems. So you will get this for mean, not for range. For range you will get normally non-overlapping intervals, and the trick is, for non-overlapping intervals we'll first convert them into overlapping intervals and then do the largest minus smallest value. So if you go down, the non-overlapping interval is also called as discrete or non-continuous. Again, too much of jargons, don't worry about that. In the exam you will just get this kind of a table. Just see what they have given. You know that the marks or the data is given as a range or into class intervals, means buckets. That's all it's called as, okay? That means it's a group data. And you see that the intervals are not overlapping. It's not continuous. This one ends at 19 and there's a gap. The next one starts at 20. So between 19 and 20, there is a gap. So it could be 19.1 onwards all the way to 19.9 kind of a thing. Again, over here, if you see, this starts with 40 and 49, and again next one starts with 50. So there is no continuity. It breaks the continuity. So again, we'll always get this problem. What will happen if the mark of the student is between these two class intervals? For example, let's say a student has got 59.5 marks, okay, somewhere in this range between. So where will you count him? Because there is no way we can count him, because there is no range or class interval defining 59.5. This kind of is 50 to 59 means anything greater than or equal to 50 and less than 59. And this means anything that is greater than or equal to 60 but definitely less than 69. So there is no interval which accommodates this student who has scored 59.5, and hence we need to accommodate somewhere and redefine the class boundaries by converting this into overlapping interval like we have it here, and then it becomes continuous, right? Because otherwise there will be always numbers like I put here in yellow. There will be always numbers like this 59.5, which is in a no man's land. The student is like orphaned or refugee. He does not know where to go, and we cannot have that. In this case, I took the example of what if a student has scored 19.5, because this interval is up to 19, it ends at 19, and this interval starts at 21, right? So what kind of you do here, right? So in that case, what we'll do is we'll redefine the limits, and the way we'll define it is like we did for mean. We'll just take the midpoint between these two intervals, and that will be the new boundary. For example, the midpoint between 19 and 20 is 19.5. The midpoint between 49 and 50 is 49.5. So there is a gap of 0.5 or 0.5 that either we need or we need to add or subtract based on whether we're talking about the lower limit or the upper limit. So that way this whole class interval range will convert them into overlapping, and that way we will not have any ambiguity. And that's what it is. If you see here, that's what it is done here. So if you see the class interval 10 to 19 as a jargon, 10 is the lower limit and 19 is the upper limit. If you take the next class interval 20 to 29, 20 is the lower limit of this class interval and 29 is the upper limit. And like I said, the trick here is to convert non-continuous or non-overlapping intervals, also called as discrete, into continuous overlapping intervals. And it's pretty simple. I put some steps here, but all you need to do is just take the midpoint and then add and divide it, or add and subtract it. For example, if you take here, this is the class interval, non-overlapping, okay, non-overlapping, and we know the midpoint. Ignore the first and the last value because there is no previous values, we'll not know, but for all other values, the midpoint between 19 and 20 is 19.5. So that means there is a 0.5 gap that we need to add. Similarly, between 29 and 30, if you take the average of these two values, for example, if you take 29 and 30, if you just average out, if you take the mean, pretty much it's a mean, right? 30 plus 29 by 2, then you will get 29.5 as the average. So like that, when you calculate, you will see that this delta is 0.5. So pretty much what you will do is you will add and subtract the delta based on whether it's a lower boundary or upper boundary. So if it's a lower boundary, lower class, for example, if we talk about, let me erase it. Okay, so we know that 0.5 is my gap for every one, or the midpoint, a midpoint gap for every interval. So let's say it's 0.5, right? 0.5. So wherever I have the lower class interval, for example, between 10 and 19, 10 is the lower class interval. So whenever I have a lower class interval, I'll subtract 0.5. Whenever I have an upper class interval, 19, I will add 0.5. So that way what happens is, in the lower class interval, you keep on subtracting minus 0.5. In the upper class interval, you keep on adding plus 0.5. Okay. And once you do the maths, you will see that the new class intervals are like this. See now 9.5 and 19.5. Then the next class interval is 19.5 and 29.5. Now we have converted this into an overlapping, because if you see 19.5 is here and over here. Again 29.5 is here and over here. So that way we have taken kind of a rule of finding the midpoint or finding the delta or the gap between those two boundaries, and we did subtract and add based on the lower and upper class, and we could easily convert that into a overlapping boundaries. And if you see here, now this is your new boundary, okay, over here. So now you have the new, instead of 10 and 19, we have got 9.5 and 19.5, and the next boundary is 19.5 and 29.5. So if you see, now we have got a continuous boundary on each one of them, and that way we can solve it. And as always, we will, how do you interpret that in terms of marks? The first boundary is any value greater than 9.5. It could be equal to 9.5, but it will be less than the upper boundary 19.5. So if you see here, there is a greater than equal to sign here, but there is only less than sign here. Similarly, so if someone has scored 19.5, he will not come in this class interval. It will be counted into this class interval. That's what it means. Okay. So now let's compare. So this is what we had originally the non-overlapping one. Okay. This is the original given problem, non-overlapping, and this we are converted into overlapping interval. So if you see the non-overlapping, 6 students have got marks between 10 to 19, and since we have converted that into an overlapping interval, 6 students have got marks between 9.5 to 19.5, and this 0.5 we know how we calculated. Okay, we just took the average, or we took the midpoint, or we just took the lower and upper boundary and divided it by 2. However you want to see it, you can see it. I given the steps over here in the first step over here. Okay. So similarly, for the next boundary, we are converted. So all this non-overlapping has been converted into overlapping boundaries. And once you convert into overlapping boundaries, it's very simple. Just take the difference of the largest value and the smallest value. So the largest value is in orange in the overlapping format, 69.5, and the smallest value is 9.5. So the value that we get is 69.5 minus 9.5 is 60. So the range for a group data with non-overlapping intervals in this case is 60. That's what it is. So if it's overlapping, then you convert into non-overlapping and then calculate. That's what it is. And as a side note, right, in some of the textbooks, what I've seen is even for non-overlapping intervals, right, they don't do this method. They directly take the difference as if it was overlapping. So what they do is they directly take this one. So if this was the given problem, they will take this value, the largest, and they'll take this as the smallest. So they'll say 69 minus 10 is equal to 60 or something like that. 61, sorry, 59, my bad. So they'll take the largest value 60, they'll take the smallest value, what I'm doing, okay, all right, okay, let's do it again. So the largest value minus smallest value, largest value is 69, smallest value is 10. So it becomes 59. That's how they calculate. But a lot of textbooks, they calculate that. But I will try to avoid that, because when I saw the paper solutions prescribed by the examination board, they normally follow this method that I spoke about, how to calculate the midpoint. So I will say avoid this. If you're going to just go by the textbooks, avoid this. If you're getting a group data, whether it's if it's a mean, if you're getting group data, if it's a mean, then calculate using the midpoint formula within that range. And if it's a range, then convert that into an overlapping boundary, again calculating the midpoint, but across the boundaries, not within the range. So like this, and subtract the delta gap from the lower and the upper, and then subtract the largest and smallest values. So that's a disclaimer. So don't follow the approaches in the textbook. In case if they have done the calculation like this, don't follow that. So with that, that's a good wrap up. And if you're interested in additional reading about overlapping, non-overlapping boundaries, not required from an exam standpoint of view, but if you're just curious, these are some of the links, and I at least referred them. They were good links. So just to make sure that they get the credits for that. Other than that, that should be a quick wrap up on this. And this is a very important topic. Like I said, you will definitely get some problems in this range, and we conclude the topic on range for group data, and then in the future episodes we might talk about solving some of the examination problems and see how it works. I'll see you in the next episode.